Right then, so we've got question 19, vectors. So we're looking at a diagram here, and it's a parallelogram. So we've got O, A, B, C, parallelogram. O to A, so from the origin, O up to A, we're calling, that's vector A. Alright, so, you can see that, vectors are, have a certain direction and a certain length. So, if you head in that direction for that long, that's called A. So this, because it's a parallelogram, this would also be called A here. It's the same distance and the same direction. Okay, so I'm just trying to give you some background of as to what vectors are. If you weren't sure, hopefully you've seen this before watching this video, revising if you like. That line there is also A, and this line up here is also vector C, because it matches the bottom one, which is C, if you travel that in that direction for that distance, okay? X is the midpoint of line AC. So if you are going from A to C, try and draw this in as neatly as possible. Okay, almost straight line. That vector there in that direction is, this is called AC, so that's vector AC. I'm trying to do AC there. That red line is vector AC. Alright, so it says that X is the midpoint in the middle. So let's mark X in, a different colour. X is going to be like, smack in the middle, let's say X. Point X is there. Alright. It says OCD is a straight line, so that OC to CD is in the ratio of K to 1. That's a lot of information there. What's it talking about? OCD is a straight line. Well, there's O to C, and point D is somewhere to make this a straight line. So we're kind of like carrying on the line till we get to D. So, D's somewhere out there, because it has to be on a straight line with OC. So you're extending it out, if you like, all the way out. Alright, and the ratio of the sizes of these two parts, O to C and then C to D, is the ratio of K to 1. So this part is called K, and then C to D is 1. That's what that bit there is kind of telling us at the moment. Alright, so we've got to find the value of K. What's the value of this bit here? In terms of like a value, rather than just a letter C. Given that XD, so X to D, this little section here, X to D, that whole set of vectors there, has a value of 3C minus a half A. So how are we going to start looking at this and trying to solve it? We need to try and work out, really, what the vector X, C, C to D is going to be. I'm going to start by working out any sort of vector we can work out. New one anyway is A to C, because we can get from A to C. It's like roads vectors. How are you going to get from A to C? You can't go straight down this red line just yet, because you don't really know what it's called. You have to find out the value of it. So the only way to get there through the vectors that we know is to travel down here and then across here. That's the only way to get from A to C. So if I do vector A to C up here, A to C, we're going to be going from A to the origin, that's our first part, plus the origin to C. That's our journey to get from A to C. And that's going down here, which is called minus A, because we're going against the arrow. So minus A plus C. So AC, so vector AC is, what did I say? It was minus A plus C. And normally we'd write this the other way around because it looks better. Alright, it's the same thing. We've got minus A there and plus C in the front. Okay, so we'll call that AC. Point X is halfway down here. So this red line is now called C minus A. We've mapped it out. Halfway would just be half of this. So half C minus half A would be half of this red line. So from X to C is half of the red line. So I'm going to make a note of this. From X to C, put some letters there. From X to C is going to give us a half C minus a half A, because it's half of that red line. Alright, so we know that journey there, that's what we can call it in terms of A and C, vectors A and C. And then we've got to work out what this part is worth here, this C to D bit. Alright, we know actually what they've told us what X to D is. So X to D, if we were travelling straight from X straight over to D, they've told us the answer. That vector there is 3C minus a half A. If I was to write that in, this one here is 3C minus, 3C minus a half A. So that's the full journey, and it's made up by these two parts here, the red line here and the blue line there. Okay, so what are we missing from our red line that we know to make the full journey? Well, we've got half a C and we've got minus half A. There's minus half A here, so that matches our minus a half A here. We're just missing some C's. We've got half C there, and we need 3C. So this bit here, the C to D, must be equal to the part that we are missing for the full journey, which is 2.5 C. Alright, you've got to think, vectors, if you're travelling in the same direction, it can only be C's because it's a straight line. So this is like 1 unit of C. This must be some more C's. There's no A's here because it's only in the same direction as the initial vector C. So that's our blue line here. Alright, and that's going to help us because we've got K, which is that part, and 1, which represents this bit here, that line C to D. So to talk about our original question where we had this ratio, we had K and 1. The 1 part was the C to D bit, the blue line, which we're saying is 2.5 C, 2.5 C. And the K bit is just worth 1 C, it's just worth 1 C. Alright, and let's say to you, well, what is the value of K in terms of a number? Well, we need to turn this side into 1, and then we'll have the value of K. We do the same thing for both sides. So what we're going to do to turn 2.5 into 1, we need to divide it by 2.5. Alright, we can cancel out the C's because it's the same on both sides. Divide this side by 2.5 and we'll have the answer. Alright, so what's 2.5 divided by 2.5 is 1. And what is 1 divided by 2.5? That's what we really need. So 1 divided by 2.5 is going to be the same as K. And this side would equal 1. This is kind of like our numerical version of this ratio here. The K is the same as 1 divided by 2.5. That's the answer. That's the value of K. 1 divided by 2.5. If you wanted to turn it into something neater, get rid of the decimals, maybe by timesing top and bottom by 10. So this is equivalent to 10 over 25, which is the same as if we what goes into both here, 5s, so maybe 2/5 is probably a better answer. But all of those are equivalent, so they would all be good answers. Difficult problem. I hope I explained that clearly enough.